Welcome to you all. The course that I am going to offer you is selected topics in decision modeling. So, in this particular introduction, let us say this much, that decision modeling is a very important component of operations research with optimization at its core. What exactly it means? It means that if we solve optimization problems which are everywhere, and from academics to the practitioners in the industry, in the service, almost in all places, in like airlines, consulting houses, operations research has become extremely important, particularly after globalization. People have realized that the old way of working is not helping anymore. We have to make our processes more efficient and more effective. Now, how can we make our processes more efficient and more effective unless we really use optimization methods? So, there are a host of optimization methods starting from linear programming and related methods, right, non-linear programming, dynamic programming, so on and so forth, network models, queuing models, simulation models. So, there are quite a large number of operations research related models. What we are going to do in this particular course, and that is why we are calling it selected topics in decision modeling, we have taken up 4 different modules. These 4 different modules are dynamic programming, integer programming, nonlinear programming and meta-heuristics. Now, what are they? Dynamic programming is a method that really helps us to solve complex decision problems, first of all by breaking them into sub problems, and then find out that there could be some recursive relationship between them, that means those sub problems, and using those recursive relationship, we solve the problem stage by stage by making use of Bellman's principle of optimality. What it essentially tells, that if I have a large problem and we have come to some distance, then forget about how we have come there, the remaining distances must be optimally solved. Is it all right? So, in other words, that if I divide the problem into stages and at stage 3 I have optimal solutions known, then come to stage 2 and consider only those things which are in stage 2 and then make use of the stage 3 optimal solutions, it should be possible to find out the final optimal solution. Now, next comes the integer programming problems. You see, in many situations what happens, the solution required is an integer. The integer could be 0 or 1, or it could be discrete values. Now, linear programming unfortunately does not guarantee an integer solutions. In many situations the integer solution is very much required, and lots of problems like your traveling salesman problem, the knapsack problems, the example could be your cargo loading problem, the fixed charge problem where you have a fixed cost and variable cost. Fixed cost does not come if you do not do the business. Those are very much available in the context of decision modeling. So, to solve those problems there are different techniques available. There are branch and bound heuristics, the cutting plane methods, then there are other heuristic methods, right. Although I called heuristics, but branch and bound is an exact method and it guarantees optimal solution. Is all right. So, all of these are discussed in integer programming. The nonlinear programming methods, which is our third topic, again another 2 weeks. Here we shall take up both constraint and unconstrained optimization problems, and methods starting from Newton's method to the use of Karush-Kuntaker conditions will be discussed, right. The last topic is the meta-heuristic, which is also has become very important in today's context, like meta-heuristics method such as genetic algorithm, simulated annealing, taboo search and other evolutionary computing methods which are all nature inspired will be also our next topic, Those are the 4 topics that we shall discuss in this particular course. As you can see, Bachelors of Engineering, Masters in Business Administration, the MBA students, the Industrial Engineering Master students, Operations Research, Operations Management people, and also the PhD people, they all can attend this course. So, it is a general course in this sense. Anyone who is interested in operations research, not from a theoretical way, but from an practical way, from a practitioner's point of view, that is what has been really attempted here. So, the difference between the existing courses, we should try more understand the concepts which are difficult concepts obviously by examples, right. So, I will try to take up more and more examples and explain the concepts through those examples. That will be our principal purpose. So, going for the detailed syllabus, the dynamic programming, the Bellman's principle of optimality, the stagecoach problems, recursive relationships, applications to shortest path and investment problems, knapsack problems, probabilistic dynamic programming and application to network problems. Integer programming module, formulation of travelling salesman problem, knapsack problems and fixed charge problems, branch and bound techniques, cutting plane methods, heuristic methods, they all will be discussed. In the nonlinear programming module, the graphic illustration, constraint and unconstrained optimization, Karush-Kuntakar conditions, they all will be used. Then search techniques, quadratic programming and also other examples. Finally, in the MetaHeuristics, the main focus will be on genetic algorithm, where selection, crossover, mutation and other mechanisms, performance, data structure, genetic search and applications. And in the second week, we shall cover more examples and along with other methods like simulated annealing, taboo search, particle swarm, optimization, etc. Right. So, in this particular course, as I said, we shall take up a practitioner's approach, taking many examples, as I said, difficult concepts, but try to understand, get a hold on the methods and techniques. That should be our journey. With that, welcome to you once again. Thank you very much.